Hi, everyone, and thanks for joining us today. We're here to talk about aluminum-intensive vehicle repair techniques. Aluminum is really driving some major changes in vehicle construction as manufacturers are using it more and more to meet government fuel economy standards. Aluminum-intensive vehicle repair techniques are a little different from what we're used to, but not difficult. ICAR's Mike Miller, who is the National Field Support Manager, and Jeffrey Poole, Performance Training Coordinator, are here with us today to provide a little bit of an overview about aluminum and the unique repair techniques that are required for working with it. So Mike and Jeff, thank you so much for being with us today. And Mike, the floor is yours.
Thanks so much, Kristen. It certainly is great to be here with you this morning. Good morning, folks. It's great to be here to speak with you on behalf of ICAR, the Inter-Industry Conference on Auto Collision Repair regarding aluminum-intensive vehicle repair techniques. My teammate Jeffrey Poole and I will go through with you today some of the interesting technologies that we're seeing changing throughout the years and in the upcoming years as it relates to aluminum-intensive vehicle repairs. ICAR was founded in 1979 as a not-for-profit training organization focused on education, knowledge, and solutions for the collision repair inter-industry. The ICAR vision is that every person has the information, knowledge, and skills required to perform complete, safe, and quality repairs for the ultimate benefit of the consumer. ICAR develops and delivers technical training programs to professionals in all areas of the collision repair inter-industry. In addition, ICAR provides a communication forum for anyone interested in proper collision repair. Our primary funding is derived from student tuition and services. This assures that our organization can become and maintain an unbiased effort in developing programs and services on an industry-wide basis. Our mission is to deliver increasingly accessible, on-demand, and relevant education, knowledge, services, and solutions for the collision repair inter-industry. A few years ago, we started speaking to the industry about the technical tsunami that we see coming as it relates to all of the new vehicle repair technologies. The first one that we saw had to do with new model introductions. According to Automotive News, there can be as many as 80 new intermodal introductions each year. And that's a lot of change for our industry to digest and have to respond to. The second tsunami that we see coming has to do with the corporate average fuel economy standards. That's driving lightweighting, or the vehicles becoming increasingly lighter in weight to improve fuel economy. By 2025, the corporate average fuel economy standard is 54.5 miles per gallon. So this means that significant changes to chassis and body structures, materials, joining methods, and the overall architecture of the vehicle that our industry is going to have to repair has to be dealt with. Aluminum is one of the key materials used in lightweighting and is now going mainstream in a big way with the introduction of the 2015 Ford F-150. And then the third advancement that we're seeing has to do with driver safety. All sorts of innovations are coming at us in the area of driver safety, or what the engineers call active safety. All of this technology has implications on our industry. It has implications on the frequency, has implications on the severity, and also significant implications on the repair process itself. You know, a lot has changed in vehicle technology since Ford in 1948 introduced the F1 pickup, which you see on the left side of the slide here on the screen. This year's introduction this fall of the 2015 F-150 is one example of a significant change in technology that has been done to vehicles. ICAR teamed up with Ford Motor Company in a collaborative development effort to create a collision repair training solution for the 2015 aluminum-intensive Ford F-150, resulting in a comprehensive and quality training program on the proper and safe repair of the next generation of Ford's extremely popular truck. Folks, this is going to be a game changer in the way that the collision repair industry approaches training. We have to be fully prepared with the knowledge, skills, and solutions needed before the vehicle debuts. Often, repair solutions are not developed until after a vehicle is publicly launched, and that leaves a gap in repair readiness. By us being able to work with Ford prior to the vehicle launch, that's allowing us to address complete, safe, and quality repairs for the new F-150 and will allow us to do so before the vehicle enters production. The training course that I-CAR has developed for this is a 6-credit-hour instructor-led course, and as you can see on the screen showing now, has a lot of good graphics and representations of repair techniques that will be used to repair this vehicle. We will educate collision repair technicians on the different types of aluminum, extrusions, and stampings used in the cab and box structures of the truck. We will also talk about various sectioning joints and locations on the vehicle. We will talk about rivet and bonding techniques, materials, and equipment repaired and required to repair this vehicle. And we'll also talk about the new high-strength steel frame design and repair. Even though this vehicle is aluminum intensive, it's still maintaining a high-strength, low-alloy frame on that vehicle. And now it's with great pleasure that I introduce my teammate, Mr. Jeffrey Poole. Jeff is a performance training coordinator for I-CAR, working in the field support department, managing instructor training for I-CAR's program instructors. With over 20 years in automotive repair, he's experienced many facets of industry life, from his start as a collision repair technician to shop ownership and insurance industry experience. Jeff has worked with I-CAR for over 15 years as an instructor and assisted in program development as well. He is ASE Master Certified in Collision Repair and is an I-CAR Platinum individual. It is with great pleasure I introduce you to Mr. Jeffrey Poole.
Thank you, Mike. Thank you, Krista. Welcome, everyone. Throughout the history of vehicle construction, we've witnessed aluminum being used in various capacities, different applications in the vehicle structure and the body. The use of this construction material, as Mike pointed out, lowers vehicle weight. This equates to that greater fuel economy the vehicle manufacturers are striving for. With the continued increase in these CAFE requirements, the vehicle manufacturers are working aggressively to meet that challenge. Alcoa Aluminum has expanded its production capability, and this is primarily due to that rising demand from vehicle makers. Other manufacturers out there are looking at this as well. Current aluminum structured vehicles that we see on the road right now are typically those luxury or performance oriented vehicles that tend to be the lower volume vehicles. But let's face it, with the F-150 coming out in 2015, there's a new kid on the block, and he's a big boy, and he's going to be a major player. So those aluminum body parts, the cab and the bed of that vehicle, those are going to be items that we're having to address out there in the collision repair industry. We still see aluminum used for body parts on other vehicles out there, hoods, closure panels, other vehicle parts. So whether it's an aluminum intensive vehicle, meaning almost the entire vehicle structure is made of aluminum, or perhaps some sort of hybrid construction being aluminum along with steels or perhaps some other composites being in there, the message is very, very clear. Expect to see a continued increase of this material in the future. What we're going to do now is we're going to take a closer look at some of what you need to know, specifically regarding aluminum vehicle construction and some of the repair techniques. So as we pointed out, the benefits of aluminum, lightweight. Okay, that's one aspect of it. There's also other benefits. What we have is we have corrosion resistance. A little bit different than with steel. Aluminum actually is, to a certain degree, self-protective as it builds an oxide coating. It has very predictable collision energy management. So from a safety stance, there's a lot of value in that material. Additionally, aluminum is highly recyclable. Some of the considerations the vehicle manufacturers have to look at is, yes, it is a little more costly for them to manufacture with this material, but again, it's time for this material to hit the market in a big way, and it is. Questions come up about aluminum and is it strong? Is it really going to perform? And so let's take a look at how they alloy. We're going to discuss how they alloy and some of the strength comparisons here just briefly. Alloying, very simply, is mixing two or more elements to formulate the final metal. So they alloy aluminum by adding some additional ingredients in there, and it can then formulate anything from what we call a 1000 series to a 7000 series alloy. The series of the aluminum alloy really depends on what elements are added in there. By changing the alloying elements, we affect the corrosion resistance, the material hardness, the workability, ductility, the welding properties, as well as others. Aluminum alloys can kind of be likened, and I kind of use this analogy to making a loaf of bread. You know, if 3 different people bake 3 different loaves of bread and they put different ingredients in, the end result is a loaf of bread, but we have different flavors and different textures. And so the vehicle engineers, they sit down and they determine the specific properties that they're looking for of that particular material that's going to be required for that vehicle component. They select the appropriate alloy for that application. A lot of folks, whenever they think of aluminum, they think of an aluminum beverage can or something of that nature. I encourage you to think about aircraft, both commercial and military, when thinking about aluminum. The history is long. The history is proven. It works. Predominantly, we see 5000 and 6000 series aluminum alloys being the predominant contenders out there in vehicle body construction. Now, just to take and go a little bit deeper there are 2 basic categories of aluminum. We have what we call the non-heat treatables and the heat treatables. So the non-heat treatable alloys, the strength of these alloys is initially produced by alloying the aluminum with additional elements, as we mentioned before. Then what they can do is they can stamp it, form it, roll it. Essentially, the work hardening process of that takes and increases the strength of that particular material. With most of the non-heat treatable alloys, there'll be a letter and a number that follows that more specifically indicates the process that that particular part went through to get its strain hardening. The other category is the heat treatable alloys. Again, the initial strength of these is also produced by the addition of alloying elements into the pure aluminum. Essentially, we're looking at the 2000, 6000, and 7000 series as our heat treatable alloys. Our 1, 3, 4, and 5000 series are the non-heat treatables. So ultimately, with the heat treatable alloys, after they formulate the initial mixture, if you will, then what they do is they go through very specific heat treatment processes that will then take and increase the strength of those materials, in some cases quite substantially. Next, we're going to take a look at aluminum part manufacturing. We're going to look at the casting, extrusion, and stamping processes and provide a little more clarity into what that means for us. Starting off with stampings, very similar to steel body parts and components where they take a sheet of steel and they stamp it with a die and press it. Essentially, that's the same thing they do with aluminum whenever they're stamping aluminum parts. Stamped parts will generally be identified by a reasonably uniform thickness, flanges for attachment to adjacent parts. You may find on some of the components there are stretch marks or areas that seem to be gathered from that forming process. Most common examples, of course, are going to be our exterior body panels, perhaps hoods, fenders, and things of that nature. We continue to see an increased use of stampings and exterior body panel applications, even on steel structured vehicles. Stampings can also be used for body structural components. They may make frame rail pieces, pillars, cross members, floor pans, wheelhouses, things of that nature on those aluminum intensive vehicles. So stamped aluminum parts generally afford the most repairability for us out in the industry when compared to extrusions or castings. So let's next take a look at the extrusion process and kind of what that means for us. So we take a look at extrusions. The upper left-hand picture is actually a cross-section of a steel rocker panel, where we perhaps have an inner rocker identified by the green, an inner reinforcement identified by the red, and then the outer rocker panel skin, if you will, or the uniside skin identified in yellow. So there we've got 3 different components that came together to make up that rocker panel. And below that, we have an extruded rocker panel of aluminum that comprises essentially all of those elements into one piece. So you can see with the extrusion process, essentially what they do is they take heated aluminum billets and they force it through heated dies. And this allows them to make some pretty complex designs if they want to, or maybe something very simple like just an open hollow tube like we see in the upper right-hand picture. Some examples of extruded structural parts can include rocker panels, reinforcements, roof rails, pillars, frame rails, things of that nature. Extrusions may have limited repairability due to the complexity of the design. You can kind of envision as you look at that rocker panel that has the lower right-hand picture that has the 4 cells with the internal walls. That's going to add some added complexity if that rocker panel is damaged and those internal walls are damaged. May limit or preclude any repairs to that depending on the location of the damage and the severity of the damage. So these are called multi-cell extrusions when they have the internal walls. Extrusions are serviceable. It really depends on the vehicle manufacturer as to what types of procedures we have. Some have sectioning procedures for extrusions. In other cases, you may be required to replace that extrusion at factory seams. Or perhaps they've got some innovative procedures where they allow a replacement of only a particular damaged cell on that particular application. Next, we'll take a look at castings. As we take a look at castings, think of, as you mold something, what they do with aluminum is they pour molten aluminum into a sand or some sort of a mold, and then it takes and cools, and it essentially forms that part. That's a very basic look at it, and there's a little more complexity to it than that, but essentially, looking at it from a collision repair stance, we really need to understand the properties of a casting. Casting tends to be a much more rigid part with, I'm going to say, less ductility, less flexibility than we have with a stamping or perhaps an extrusion even. Castings can have a variety of shapes and thicknesses as well as varying cross-section of that particular part. Castings are typically attached to other parts with MIG welds, or they may be bolts or rivet bonding used. Again, really up to the vehicle manufacturer. In some vehicle body construction, castings can also be used as joints where multiple parts come together. These are typically referred to as cast nodes, as they kind of use them as building blocks in that vehicle structure. We find that in some vehicles we have strut towers, pillars, frame sections, as well as some of the suspension parts and some of their mounting locations as examples of where castings can be used in that body structure. Castings generally have a rough textured surface. That's from the casting process. Typically they are irregular in shape, and they may have machined surfaces with tapped holes and things of that nature for attachment parts. Damaged castings, for the most part, will be replaced. This may require reattachment using bolts, rivets, rivet bonding, or possibly some MIG welding involved there. Again, there's very specific information from vehicle manufacturers regarding this. There may be repair procedures for threaded attachment points that are damaged as well. A couple of additional things I want to touch on real quick before we go deeper into some of the repair items. First one is galvanic corrosion. The vehicle manufacturers strive to build vehicles that are going to have longevity, performance, safety. Ultimately, corrosion is a concern. The vehicle manufacturers put a lot of research and effort into minimizing, eliminating galvanic corrosion issues. So understanding what galvanic corrosion is. Specifically, galvanic corrosion occurs whenever we have dissimilar metals in contact with each other, and there's an electrolyte present, and we have oxygen, air, in that equation. What that actually does is turns that into a small galvanic battery, and then electrons start flowing. When electrons start flowing, materials start to break down, decompose. We start to get that corrosion. So ultimately, the vehicle manufacturers do take steps to minimize this occurrence. This includes using specially coated fasteners, having coatings, sealers, or adhesives between panels, using non-conductive urethanes for glass, and there's a variety of other techniques they might employ as well. During the repair process, we need to keep this in mind. This is a consideration. Generally, the OEM will have specific recommendations during repair for us to follow. Again, we just need to think about how's that part going to perform in the future, what's the longevity of that repair going to be, and have we taken the right steps to minimize that galvanic corrosion issue going forward. Another characteristic trait of aluminum is its work hardening characteristics. When we're making repair and replace decisions, it's critical that we understand the properties of the materials that we're dealing with. Aluminum has a very high rate of work hardening. Now, it does vary with the specific alloy that we're dealing with, but this work hardening characteristic may cause it to crack when it's damaged, or it may crack during the repair process as we start to pull, stress relieve, and realign structural components. This really, again, varies based on the alloy, thickness, and the manufacture method of that part. Really, aluminum doesn't want to return to its pre-damage condition, and it may require a refined approach whenever it comes to our techniques that we apply to that vehicle. Let's talk for just a minute about heating considerations. This is something else we need to have an understanding of the material we're dealing with and the attachment method of that material to that vehicle structure. I have to start this off with always follow the OEM service information guidelines regarding part repair and any heating limitations, or perhaps they have statements that prohibit repairs or the use of heat during repairs. Approaching this from a more generic stance, minor damage may be repairable cold. However, what we've found, and folks out in the industry that are working on these vehicles already, so far as the aluminum intensive vehicles that are out on the road, they've for the most part found that heat will help increase our chances of repairing a damaged aluminum component. We do have to be cautious that we follow heat limitations, the guidelines applied to using heat there. Limited heat can assist in moving the aluminum molecules and to help reduce the tendency of a part to crack. If heat is going to be used, do not exceed the OEM recommendations. As a general rule, you should not exceed 450 degrees Fahrenheit on any part that you're heating. Ultimately, there is a certain point, and generally that's about 650 degrees, upwards of 750 degrees, depending on the alloy, where we may anneal or permanently soften that aluminum alloy, totally destroy its properties. We always want to make sure we're monitoring heat if we're applying heat. Something else to keep in mind, heat spreads very quickly on aluminum. We have to consider the location of adhesives, foams, and other materials which may be affected or compromised by that heat propagation through that material. So again, a bit more to think about as we're approaching repairs on these materials. Damage analysis. So in what I've covered so far, we've already touched on some key points. And as we're developing a repair plan where aluminum is involved, we really want to pay particular attention to the joining areas, adhesive and riveted joints. They may not give the appearance of damage, but close visual inspection could identify where a bond line has been compromised or a joining area has been compromised. Perhaps as we look at welds, inspect them very closely to identify has the weld cracked. In many cases, whenever parts are joined by welding, that weld may be, I want to say, the weak link in that vehicle construction. And that's there by design. The vehicle manufacturers, if they've welded those components together at the factory, they understand exactly what they're doing and what the implications of welding that material are. So as we take and we inspect that vehicle, it's just one of those key points that, hey, take a closer look at the welds where parts are joined together. Especially where you've got an extrusion coming together with a casting. That extrusion is going to have a certain ductility, and that casting is going to have perhaps a different ductility. And so that puts perhaps additional stress and strain on those welded joints. We also want to take a look at rivet locations, bolt locations, and things of that nature to identify if there's any gaps or separation or shearing of any of those components. In some cases, die penetrants may be called upon to help find cracks in damaged or repaired parts and weld beads. With the possible use of stampings, extrusions, and castings in mind, again, we have to consider how each responds to collision energy, how it's absorbed or transferred through those vehicle structural components, and each may respond just a little bit differently. Again, this is by design. We just want to make sure we're being thorough and prudent in our inspections of the vehicle. It comes to measuring of these vehicles. I look at vehicle tolerances, build tolerances over the past years, and they've tightened up substantially. I think back to earlier vehicle construction where we'd pull a vehicle apart, disassemble a vehicle, and we'd have a lot of shims coming out from behind the fenders and things like that. You just don't see that these days. So really, as we take a look at measuring, first question I put up there is, do you have a plan? Do you know where you're at, and do you know where you need to be? And that's what measuring does for us. It allows us to understand where that structure is at and where that structure needs to be. So measuring that vehicle structure is critical for complete damage analysis and during the repair process, as well as documenting the repair process. With the exacting build tolerances of today's vehicles, three-dimensional measuring is critical. This can include the use of universal or dedicated fixture systems or computerized measuring. Some vehicle manufacturers may have specific requirements in these areas. In some cases, there's limited data available. Also keep in mind magnetic hangers, they don't work too well on aluminum. Now we still have steel fasteners that some of those magnetic attachment hangers will affix to. Just as a note, on July 7th, ICAR is going to launch an all-new instructor-led course called Documentation in Digital Photography. This is designed to train industry professionals in an interactive shop setting on the use of cameras and additional details on the documentation processes that we should be employing during the repair of vehicles. Throughout the planning and repair process, of course, OEM service procedures should be documented and followed as well. When it comes to straightening aluminum structures, and aluminum components, there is no general rule when we're going down this path. Again, we have to keep in mind that aluminum doesn't want to go back where it was. Aluminum has that very poor memory characteristic. It resists those straightening attempts. So when we're evaluating what may or may not repaired, we have to ask ourselves a few questions. Is the part a stamping, a casting, or an extrusion? How's the part going to respond? What's the extent of the damage to the part? Part thickness becomes a consideration. The thicker the part, the harder it is to straighten. Kink versus bend is not really applicable to aluminum components. As we're starting to pull and realign vehicle structure, we have to, in some cases, slightly over pull, depending on the situation, to account for some of the spring back. We really have to take a look at our adjacent joining areas to make sure we're not pulling the adjacent joining areas apart where we may have rivet bonding or welded joints and things of that nature. So we'll need to monitor our pulls, keep an eye out for induced damage on adjacent parts, as well as keeping an eye on our actual anchoring locations on that vehicle so we're not inducing damage there either. Stress relieving techniques should also be used during our straightening attempts. When it comes to cutting, drilling, and grinding, there's some things that we want to keep in mind as well. As we look at part replacement, drilling and cutting can generally be done at high speeds. We want to make sure that the tools that we're using are appropriate for aluminum. Typically our drill bits that we use on steel are similar design to what we'll use on aluminum, but it is a good practice and recommendation to use a separate set of tools whenever it comes to these so that they're not pre-contaminated with steel particles and things of that nature that potentially become a galvanic corrosion issue. The cutting burrs, the rotary cutting burrs used on aluminum are substantially different from the ones used on steel. The rotary cutting burrs used on a die grinder for steel are very fine in nature, whereas the ones used for aluminum are much more aggressive and help resist clogging of that. There may be recommendations in some cases for a lubricant to be used with some of the operations that we do. When it comes to sanding and grinding, this should typically be done at lower speeds with light pressure. That'll help avoid clogging the abrasive and building up excessive heat that's not necessary. There are abrasives out there that are specifically designed for aluminum that perform much better than some of our general abrasives that we have. Again, be sure that the abrasives have not been used on any other materials. Again, the word here is to avoid cross-contamination. Dedicated tools and equipment may also be called out. Again, an available clean repair area. This may include, but not necessarily limited to, a curtain wall or something of that nature where we can get a clean area in the shop, perhaps explosion-proof dust collection system, as well as other tools and equipment that might be required. As we take a look at part attachment, first we'll look at OEM, then we'll take a look at repair part attachment, what we do in the service industry. Vehicle manufacturer can draw from a variety of attachment methods. This can include mechanical fasteners, we have our bolts and flow drill screws, rivets, clinches, perhaps hemming, and adhesives used in a combination of these joining methods. Or perhaps they use welding. In some cases, we may not be able to reproduce the original installation method, so we'll take again a look at some of the repair methods. Keep in mind the track record of rivets in the aerospace industry. There are a lot of rivets and structural adhesive flying around the world right now. So as we look at repair fastener considerations, it's again absolutely critical to reference the OEM repair information to identify the correct fasteners and methods to put that vehicle back together. It's not a matter of personal opinion on how it should be done. These are tried and tested methods that the vehicle manufacturers come up with. In some cases, this may include actually duplicating the original installation, or in some cases, they may specify alternative installation methods. So we'll take a closer look at some of these as we move along. First thing we'll look at is the clinch. Clinches are done during the part or vehicle manufacture. primarily done on non-primary structural applications. We see it quite commonly on aluminum hoods, trunk lids, some cases on doors or quarter panels, down to the floor extensions, or perhaps on a fender attachment bracket. A clinch is not a separate fastener, but rather they use a press and a die to take and form it on the assembly line where it draws the metal up through itself, kind of like a soda can tap. Currently, we have no way to reproduce that in the shop environment. So if we find ourselves in a situation where we need to take and replace a clinch, typically this is done with rivets and bonding. When it comes to bolts, we want to pay particular attention to threaded fasteners. They're likely to be coated to reduce galvanic corrosion issues. This coating is generally a baked-on coating at elevated temperature as a final step in the manufacture process of that hardware. So there's no equivalent brush-on replacement for that coating. In some cases, the procedures may indicate replacement if the bolt is loosened or removed. In other cases, it may be acceptable to reuse the fastener if the coatings are still in good condition. A careful inspection and attention to detail, again, is important as the vehicle is disassembled. Make sure we have the correct fasteners on hand as it goes back together and observe torquing specifications. When it comes to rivets, there's some interesting tools out there on the market to address some of the different rivets that are required to put the vehicles back together. Procedures may call for solid rivets, blind rivets, or self-piercing rivets. Again, it's important we identify the right type of rivet, correct size, and installation location for that particular application, and identify the correct tools and equipment to do that. We do have a few situations out there where rivets are called for in place of welding. Some of the folks out in the industry are already familiar with self-piercing rivets. For others, this may be something that we're not so familiar with. A self-piercing rivet is actually a coated steel rivet that is pressed in using a special press and die set up on the assembly line, where they press that rivet into the panel, and it does not protrude through the back of the panel. It actually goes in and spreads out to join those panels together. Now, this rivet does not require a hole to install. To take and remove these rivets, we take and we look at using either a press tool to take and press them out. There may be procedures that include grinding the backside of the rivet and punching it out, drilling the rivet. In either of those cases, we have to think about what's happening to the potential steel particles that are being generated, and do we have the proper dust collection system to take and address that to help minimize galvanic corrosion issues. Or perhaps there's a special stud welder tool that's called for. Installation definitely requires the correct press tool and dies. As we look at replacement SPRs, they would typically be replaced adjacent to the original location. Some procedures do allow for the use of blind rivets or full rivets instead of SPRs. So again, this is a situation where as rivets go in, generally we're going to be using structural adhesives on the mating flanges as well. So let's take a look at some bonding preparation procedures next. When it comes to bonding and the use of adhesives, we want to make sure that we follow the correct flange preparation steps. Again, this is another absolutely critical element to this process and to ensuring that the strength is there. A thorough understanding of surface preparation steps, material preparation, application, clamping, and installation of fasteners within the work times of that adhesive. This all has to be taken into account of. That way that vehicle is restored to the design intent. Some part replacement procedures may require the vehicle to remain in fixtures for a certain period of time after that part's installed. ICAR has an adhesive bonding course. It's an excellent resource to learn more about adhesives. During repairs, we may find it's necessary to apply welding techniques. MIG welding is the predominant technique used out in the industry for repairs and collision repair industry. This may include plug welds, fillet welds, butt joint with backing, and open butt joint welds. We want to make sure we identify the correct shielding gas. Generally, this is 100% argon gas. We want to identify that we have the correct purity of shielding gas. Another element we have to identify is the correct electrode wire, alloy and diameter, as well as getting our equipment set up, and then put into that equation the skills necessary to make those welds in order that we have the correct outcome. Correct surface preparation and joint fit up are also major contributors as well. I can't stress enough the necessity to make and do practice welds before we strike an arc on that vehicle. Welding aluminum takes some time to get proficient. Some gain proficiency rather quickly. Other folks out in the industry, it takes a little longer for them to adjust. to the techniques required. With aluminum welding, we use a push technique. The joint fit up is absolutely critical and surgically clean. No weld through primer or other coatings within that weld vicinity. A lot of discussions out in the industry about what welding equipment. Predominantly what we're seeing is pulse type welding equipment is the recommendation or requirement in most situations. The electrode wire, again, is critical as that electrode wire mixes with the base alloys that we're welding together. This affects the final joint strength. Are your technicians up to the ultimate tests? Is that vehicle going to be up to the ultimate test? We've covered a lot of information in the presentation so far. There's only so much we can cover in the available time. I'd like to encourage you to attend classes that go into more depth. This time we're going to turn it back over to Mr. Mike Miller for some additional information regarding welding and training. Mike?
Well, thank you so much, Jeff, for the presentation that you just shared with the industry on the aluminum intensive repair technologies that we're seeing coming down the pike and continuing to see as the industry moves toward making the vehicles lighter. The tea leaves are telling us out there that aluminum repairs and aluminum welding are going to be critical in upcoming years because of the need to make the vehicles lighter. So why should we want to train? Well, ICAR has done statistics to show that approximately 6% of the industry's technicians are fully capable and fully trained on aluminum welding. That leaves a huge void of about 94% that really need this training in order to repair the new upcoming vehicle technologies. And so we asked the industry two questions. We asked, do you believe poor or improper welds on structural repairs lead to compromised structural integrity? And then we also asked, do you believe compromised structural integrity can result in decreased occupant safety? And of course, the answer to both of those questions is a resounding yes. You know, the industry knows that welding is important. We know that bad welds compromise vehicle safety, and we know that bad welding will put customers at risk. And with new vehicle designs and materials such as aluminum and high and ultra high strength steels, welding training is now more critical than ever. Aligned with the ICAR vision, ICAR has a role to ensure that every technician who welds in a shop has the training needed to complete safe and proper welds for the safety of the customer. This is not only for aluminum, but also for steel. ICAR has revamped its welding training and certification offerings and lowered prices to make it more affordable for shops to train all of its technicians who weld. The ICAR Welding Training and Certification Program is an in-shop, hands-on, skill-based program. We bring in an ICAR-trained welding instructor who goes in and does a three-part assessment on the facility. They're looking at the infrastructure of the repair facility itself, making sure all the electrical requirements and the welding equipment is up to speed. We look at the other equipment that's necessary to perform these quality welds. And we also look at the technician's skill and make sure that we work with the technician to coach and mentor them on the proper techniques as it relates to the type of welding in which they are performing. We also go further to teach technicians and give them information they can take back the next day to their work on how to appropriately practice, do visual inspection, and destructively test the welds in which they've done prior to ever welding on the vehicle. That's important because setup on a welder is so important prior to going and doing the actual repair on the vehicle. The certification test is conducted again in the repair facility, and at the end of it, the welding training and certification credentials for the appropriate test, whether it be the steel sectioning, or aluminum test, is awarded that day. Also in July of 2010, ICAR introduced to the industry the ICAR Professional Development Program. This was a program where technicians, depending on the role that they serve in the industry, are trained with specific information as it relates directly to that role. No longer will a refinish technician be taking a steering and suspension class, for example, to meet the qualifications to train for that refinish technician's role. So it got more alignment for the technicians to be trained in the areas in which they are working on a daily basis. We also, in January of this year, introduced the new ICAR welding training and certification program, as well as we have platinum and gold class designations, the platinum being for an individual and the gold class being for a company or repair facility location, in order to show that they have achieved that higher level of repair. This allows the industry to have established reference points for even hiring situations. We have found that some organizations have some catching up to do, as we wish to eliminate many areas where we assume training and knowledge within our workforce already exists. This has been the single largest movement within our industry as it relates to training and professional development. And as always, you can learn more about ICAR and the ICAR programs at our website. It's www.i-car.com. You can also learn about welding training and certification. Go to the ICAR website, i-car.com/welding, or call our customer care center at 800-422-7872. Folks, I'd like to thank Krista McNamara and the fine folks at ABRN for allowing us the opportunity to speak with you today regarding these very important topics as it relates to the collision repair industry training. I also want to thank you as attendees for the professionalism that you represent to the industry, and keep the theme in knowing that it's always what you learn after you know it all that really counts. Thank you so much, and I look forward to speaking with you on upcoming webinars.